Good morning or afternoon whenever you're watching this. Let's go into chapter 3.2, solving quadratic equations. So the first thing we're going to talk about is the zero product property. If the product of two real numbers is 0, then at least one of them must be at 0. That is, for real numbers a and b, if the product of a times b equals 0, then either a equals 0, b equals 0, or both a and b are equal to 0. So we're going to use this property to solve quadratic equations by factoring. So if we look at our first example here, we've got 3x squared plus 7x plus or equals 6. So now with this, the first thing you're going to want to do is you're going to want to get everything on one side. So you've got 3x squared plus 7x. You're going to want to bring that 6 to this side, so we'll subtract it over, and then it'll equal 0. Now you got to worry about factoring. So we're going to have our two parentheses here. We're going to set that equal to 0. And this is where our a times our b equals 0 comes into effect, because either this one has to equal 0 or this one has to equal 0. Well, let's figure out what goes where first. So our factor here is a 3x squared. So we know that one of them has to be a 3x and one of them has to be a 1x. Okay. Now we've got a negative 6 here. So we've got to have two numbers that multiply to give us a 6 and actually give us a negative 6. That means one of them is going to be positive, one of them is going to be negative. Okay. And the middle number here is positive, which means that it really needs to go with the bigger number. Meaning that over here, if I look at my factors of 6, I could have 6 and 1, I could have 3 and 2. Okay. Well, 3 times 6 is going to wind up giving you an 18. That's way too big. 3 times 3 is going to give you a 9, minus a 2 is going to give you a 7. So if I do 3 here, I do a minus 2 here, it should factor out. 3x times 3 is going to 9x, 2 negative 2 times 1x is negative 2x, which adds to give you that 7x, and everything else works out as well. Now, if you have a different method of factoring, by all means, go ahead and do that, no problem. Alright, so now we're going to do the whole AB thing here. So if I come up here, let's change my marker color. So we need to set both of them here equal to 0. So what we'll do is we'll do 3x minus 2 equals 0, and we will also do 1x plus 3 equals 0. Okay, and then we just solve for x on both of them. So here we get a 3x equals 2, so that x equals 2 over 3. Over here, we get an x equals negative 3. If you need to take a few more steps to solve those, by all means, be my guest, take a few more steps. But that's what your answers look like. Pretty simple. So let's look at this second one down here. Now, this one says, let's change colors again. This one says S of t equals 80 plus 64t minus 16t squared. So when I see this, my first thought here is I can pull something out. Okay, I know I could pull a 2 out because all these are divisible by 2, but I could pull out something that's bigger than 2. 4 works, 8 works, 16 actually works too. So if we pull 16 out of this, and we want to solve this by factoring, so actually the very first thing we do is we set the whole thing equal to 0. So by setting it equal to 0, it's essentially the same thing, and we're going to find our two zeros here. But like I said, we could pull out a 16. If we pulled out a 16, it'll make it a whole lot easier to factor. Okay, now if we look at this, you got to figure out how many times 16 goes into 80. If you have your calculator, you can make that really, really simple here. So we're looking at 80 divided by 16. Just to double check myself. Yep, it's 5. So if I pull a 16 out of 80, I get 5. If I pull a 16 out of 64, I get 4. If I pull a 16 out of 16, I get a negative 1 here, and that's t squared. Okay. Now, I want to solve this, so I'm going to go ahead and divide off this 16 here on both sides. 16 divided by 16 is 1, 0 divided by 16 is still 0. So that what I get is 0 equals just this factored portion right here, or unfactored portion. Now we can factor it. So what I have is two parentheses here. Okay. Now, if you wanted to, you could come over here and you could rewrite it if it makes you feel better. You could rewrite it as negative t squared plus 4t plus 5 equals 0. And something that also helps people sometimes. So let's go ahead and is if you come over here, add notes. So if I came over here, sometimes it also helps. You could pull out a negative 1 here if you wanted to, because sometimes people don't like the negative in front of your t squared. If you did that, you would have a t squared minus 4t minus 5 equals 0. Because if you pulled out a negative 1, you pull a negative out of 0 too, it's still just going to be 0. And sometimes it's easier to factor when you have a 1 in front of your t squared rather than a negative or any other number. Okay, because then all you're going to have here is a t and a t. You need two things that multiply to give you negative 5, add to give you negative 4. That's pretty easy. How about a negative 5 and a positive 1? So that your t's here, t equals negative 1 and t also equals positive 5. And those would be your two answers for this one. Easy enough. If you'd have left a negative in there, it still would have factored. So you could have factored this just fine. You could have also factored this just fine. Taking the negative out just makes it a little easier. But it still would have factored. You'd got the same answers. Okay. The next one says daily profit P of x equals negative 0.01x squared plus 20x minus 500. What is the most profit you can make daily? Okay. So if we look at this one, right? So if you're thinking about it, it's a squared function, right? So P of x is your profit here, right? So it's if I draw it, okay, you got a negative here. So what it's going to look like is you're going to have a maximum point up here, right? Easy enough. So with that maximum point, you want to figure out exactly where it's at, okay? So that what we could do, you could do a few different methods, okay? You could find your maximum point, right? Or you could just graph it, okay? I'm always the one that likes to take the easiest way. So if we take it, let's go over here real quick to our TI. Let's take it, graph it, and find the most profit that you can make daily. Alright, we want to figure out how much profit we can make in a day. We've got our equation typed in here in Y1. So if you're not with me, hit Y equals, type your equation into Y1. Now, I'm going to zoom standard, see if that does me any good. Probably won't, but sometimes it does. Let's see. No dice on the standard. So usually go zoom fit after that. Still not a very good picture. So I'm going to go zoom out. And I'm going to go up here to the left hand side. So I'm going to scroll up here to this very top right hand corner. And that's where I'm going to zoom out at. Now I can see a little bit more of it, but I'm still not seeing the whole picture. So I'm going to do the same thing and do it again. I want to do it till I can see the maximum point, the upper curve. And it might take a while. So if it does, you just got to bear with it. And just keep zooming until you get there. Sometimes it can be a real pain. Sometimes it takes 5 or 10 times. But there we go. We made it, right? So we want to know the maximum we can make per day. So that's obviously going to be this very top point here. So we can go second calc maximum, right? So we'll go left of what we think the maximum point is, hit enter. We'll go right of what we think the maximum point is, we'll hit enter. And then we'll guess what we think the maximum point is and hit enter. And it tells us we have a maximum at x equals basically 1,000 and y equals 9,500. Okay, so remember those numbers, and let's go right back on over here to our notes. Alright, so we're back over here at the notes. Alright, most profits you can make daily. Okay, P of X is your daily profit. So that's essentially your Y, right? So the Y value is actually the most profit you can make in a day. So the answer for this one will be $9,500. Easy enough. Like I said, I like to go through and find the easiest way to do it. That's just me. If you want to go through and use the little hand method that we discussed last section, by all means, go ahead and be my guest and do that. Alright, factor theorem. The polynomial function f has a factor x equals a if and only if f of a equals 0. Thus, x minus a is a factor of f of x if and only if a equals, or x equals a is a solution to f of x equals 0. So we're going to solve 0 equals 3x squared minus x minus 10. And we're going to graphically find one of the x-intercepts, algebraically verify that the 0 found in part A is an exact solution, and use a method of factoring to find the other solution. So that means, that means that we need to go over to the TI really quick and put this in and graph it. And then we'll find one of the x-intercepts, and then we will find the other using a method of factoring. Okay, so follow me over to TI real quick. Get yours ready. Alrighty, so we're over here at the TI. I've got it typed in my y equals. Okay, so all I did was type the equation in. Don't worry about the equals 0 part. So what we're going to do now is we're going to graph, and we're going to find one of our x-intercepts here. So I'm going to do zoom standard like I always do. I always like to start out with zoom standard and then adjust accordingly. So this actually does a pretty good job. We know it's a parabola. We can see the parabola shape, and the main thing we're worried about is where it crosses the x-axis, and we can see both times that happens. Okay, so if I come over here and I do second calc, I can say, okay, I need to calculate here. So I'm going to calculate a 0. Okay, and I'm going to do this one over here on the left just to do it. Okay, so I'm going to go left of where it crosses the x-axis, right of where it crosses the x-axis, and then I'm going to come over here and I'm going to guess and say, okay, it crosses somewhere around here. And what it tells me is that one of my zeros is negative 1.66666 repeating. Okay, so negative 1 2/3. Easy enough. So keep that one in the back of your mind. I'm going to go ahead and find the other one graphically as well, just to show you that you can find both of them graphically, although we're going to wind up finding at least one of them by hand as well. So if I find this one graphically, it looks like it's going to be 2, but it's better to verify with exact numbers. You do the same thing, left bound, right bound, and then guess where it's at. Doesn't have to be exact, and it tells you that one of your zeros is x equals 2, y equals 0. Okay, so got both of those in mind. Let's go back to your notes and begin filling it back out. So this part A right here, it says graphically find one of the x-intercepts. So we did that, and we saw that x equals 2 was 1. So let's go with that x equals 2 for 1. And we'll see if we can find that negative 1.6666 repeating by using a method of factoring. Okay, so what we're going to do here says algebraically verify that the 0 found in part A is an exact solution to this. Okay, well that's easy enough. The easy way to algebraically verify it is just plug x equals 2 in and see if it actually equals 0. So if I do this, 0 equals 3 times 2 squared minus 2 minus 10. Now 2 squared is 4, right? So this will wind up being 4 times 3 is 12, minus 2 minus 10. And if you're looking at that, that does indeed equal 0, which is what it needs to equal. So it works. Okay. Now part C says use a method of factoring to find the other solution. Okay. This one might be where it gets a little harder for you. But essentially what we're going to do, if we're looking at this, we've got x equals 2 as a solution. So let me go ahead and back solve this for you. Sometimes it helps if I back solve it. Okay, so I'm going to do it over here. So if x, oops, gotta find my marker here. Let's go ahead and change colors too. So if x equals 2 is a solution, that means that x minus 2 equals 0, which means that x minus 2 is going to be one of your factors. Okay, so that one of our factors here is x minus 2. Okay, now if we're looking at this equation right here, 3x minus x minus 10 equals 0, we've got one of the factors here for it. Well, the other thing is I can already tell you that this solution here has to be 3x, because I have to wind up with 3x times x equals 3x squared. Okay, so I've solved part of it. Now I also need a 10, right? Which means that whatever this last number here is multiplied needs to give me a 10. So what times negative 2 gives you negative 10? A positive 5. Oops. So if we look at it, we've solved it. 3x times x is 3x squared. X times 5 is going to give us a 5x. Negative 2 times 3x is going to give us a negative 6x, which gives us a negative x, and negative 2 times 5 gives us a negative 10. So we have found the factorization of it. So all this equals 0. We've already found that x minus 2 equals 0 gives us that x equals 2. We solve the other one, 3x plus 5 equals 0. What we wind up with is 3x equals negative 5. So that so that x equals negative 5 over 3. So here's our two solutions, which is exactly what the calculator found as well, because we found it to be negative 1.666 repeating. That's the exact same thing as negative 5 over 3. So if we move on, we've got the square root method next. So the solutions of the quadratic equation x squared equals c are x equals plus or minus the square root of c. Note this method can be used to solve equations in the form of ax plus b squared equals c as well. So in this example here, what we've got a 2x squared minus 16 equals 0. So let's go ahead and solve out for x. So I get 2x. I'm going to add this 16 to both sides. Okay, so 2x equals 16. And then what I'm going to do is divide by 2 so that I get x squared equals 8. Now I need to get rid of this squared. So using my definition up here, what I can say is that this is the same thing as x equals plus or minus the square root of 8. Now I do need to simplify that square root of 8. If I do that, what I can notice here is if I break that 8 up into 4 times 2, okay, that's multiply right there. Okay, 4 times 2, the square root of 4 is 2. So that what it looks like is plus or minus 2 square root 2. That would be the solution that it would be looking for. Now, like it says, what you can do here, this next one, is you can use it and go ahead and take the square root at the beginning if that's how it's set up. So here, I can change this to x minus 6 equals plus or minus the square root of 18. Okay. Now, 18 breaks up into 9 and 2, and 9 has a square root. Okay, so that what it looks like is x minus 6 equals plus or minus 3 square root 2. Now you still need to get x by itself, so we're going to add 6 over. If we do that, we get x equals 6 plus or minus 3 square root 2. And that's how that works. So the square root property really comes in handy. It's really a nice, neat, simple property to use. Now let's look at completing the square. Now completing the square is usually something that people really hate doing, but it's honestly not as bad as people make it out to be. So let's just start with this example here. The first thing that you're really going to want to do if you're completing the square, what I always do, I get my x parts together, and then I bring that constant over the other side, and I leave me a big gap. So essentially what it looks like is this. X squared minus 12x, leave yourself a gap, equals negative 7. Okay. Now, if you're thinking about it here, okay, so what we're going to do, if I was to factor this left-hand side, okay, I've got an x here, I've got an x here, right? So I need two things that multiply to give me two of the same things, okay, because it completes the square. Two of the same things that multiply and give me a number that I'm not sure of, but also add to give me negative 12, okay? So what are two of the same numbers that add to give you negative 12? So essentially, what is half of negative 12? It'd be negative 6 and negative 6. Okay. So negative 6 times negative 6 is a positive 36. So now we know what to put here. Let me change the color so you'll see that. So positive 36. And what you do to one side, you have to do the other. So we get a positive 36 here as well. Okay. So that if we go through here, x times x is x squared. X times negative 6 plus x times negative 6 gives you negative 12x. Negative 6 times negative 6 is positive 36. And you have to do that positive 36 to both sides. Okay. So that when you do your equal sign here, negative 7 plus 36, if you want to go ahead and simplify, is going to be a 29. And you're like, okay, what was the whole purpose of doing that? The whole purpose of doing that was to use your square root property. Okay, so that you write this as x minus 6 squared equals 29, so that you can go ahead and say, okay, that means x minus 6 equals plus or minus the square root of 29, which means x equals 6 plus or minus the square root of 29. And that is how completing the square works. Okay, more formally, what winds up happening here is kind of definition wise, what you wind up with is an x plus a squared at the end. Therefore, when you FOIL that back out, what you get is x squared plus 2ax plus a squared, so that the a is a half of your b, because typically you have an a, b, and a c here. And that's just typically how it works. I mean, it's really not that hard. So that a squared on the end is just the squared part, or this part multiplied by itself. Okay. We don't do a whole lot of completing square examples in this class. A lot of times what I find that students wind up doing, instead of figuring out how to complete the square, they just go ahead and jump and memorize the quadratic formula, because you have to memorize it anyway, and they'll just do the quadratic formula instead of completing the square. But if you can get used to completing the square, it's really not that difficult to do once you get the process down. So speaking of the quadratic formula, the solutions of the quadratic equation ax squared plus bx plus c equals 0 are given by the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Note that a is the coefficient of x squared, b is the coefficient of x, and c is the constant term, as it says right here. This is how your equation's set up, right there. Okay. Alright, so let's do some problems with the quadratic equation. So we want to solve this one using the quadratic. Okay. So what I got to notice here, my a is the negative 3, my b is the 4, and my c is the 6. If you want to rewrite it in the standard form, like this, so that your a, b's, and c's flow properly, you can do that as well. But it doesn't have to be in this form. You should still be able to figure out what your a, b, and c's are. Okay, so that if we use the quadratic equation, negative b plus or minus the square root of b squared minus 4 times a, which here is a negative 3, times c, which is a 6. And you do have to include that negative. If it's out in front of any of these, you have to include the negative. That's very important. If you don't, you will get the question wrong. All over 2 times our a here is a negative 3. Now it's just a simplification process that we got to work on here. So that what we get is negative 4 plus or minus the square root. 4 squared is 16. Negative 4 times negative 3 is positive 12. positive 12 times 6 should be 72. Okay. All over 2 times negative 3 is negative 6. Still got some simplifying to do. We get negative 4 plus or minus the square root. Okay, 16 plus 72 should wind up giving you 88 over negative 6. I believe that's right. 12 minus 32. Yep. And it always helps to double check, try not to get anything wrong. If you ever see me get anything wrong, let me know by email. Probably get some extra bonus points. Still got to simplify this. So let's look at the square root of 88. Okay. So if I'm looking at the square root of 88, it obviously doesn't give you a very nice, easy whole number. But if I'm looking at what divides into 88, 11 does, but 11 doesn't have a square root. 8 does. 8 actually doesn't have a square root either. 4 definitely does. How many times does 4 go into 88? 4 goes into 88 22 times. So let's go ahead and pull that out. So that what we're looking at here is negative 4 plus or minus. If we pulled that 4 out, and I'll go ahead and do the extra step. 4 times 22 over negative 6. So if I go ahead and take the square root of that negative, or that 4, what I get is 2 square root 22 all over 6, negative 6. And what you can do here, I know I'm running out of space, you can cancel this negative out here, and you could actually cancel a 2 out as well. So if I pull a 2 out of everything, I get a positive 2 here, plus or minus. This 2 cancels out, so I've got a square root of 22. And this negative, I'm canceling with this negative and this and this. So the plus or minus doesn't change when you cancel a negative out, but it changes everywhere else. So that your simplified version here is 2 plus or minus the square root of 22 over 3. And like I said, to reiterate what happened here is essentially I canceled a negative 2 out of everything. So I canceled a negative 2 out of this, I canceled a negative 2 out of that, and I canceled a negative 2 out of that. Now the negative 2 got rid of the negative here and the negative here, but this is a plus or minus, so essentially all it did was change it to a minus plus, which is the same thing, which is how we got here to our final answer. Simplification can sometimes be tricky, but the overall process really isn't that bad. Okay. The next question says, if c of x equals 2.224x squared minus 29.841x plus 353.300 and x equals the number of years after 1970. Find the year after 1970 the model predicts the expenditures will reach 5,227 billion. Okay, so it says use the quadratic equation and then show graphically. The thing with this is, what you're going to have to do to start out is you got to know how to write the equation. We want to know when the expenditures are going to be 5,227 billion. Everything's already in billions, so I'm just going to write 5,227 equals 2.224x squared minus 29.8141x plus 353.300. Now the biggest thing here is I need to combine my constants and get everything on one side and equal to 0. So if this side needs to be 0, then essentially what I'm doing is subtracting off 5,227 here and here. Okay, so that what I get, this part stays the same. And let's see, let's simplify this side. So what we get is negative 5,227 plus 353.3. We get minus here 4,873.7. Okay, so that what I'm looking at here I'm going to take this. I'm going to take that and I'm going to put it in my calculator. Now it does say that it wants us to use the quadratic equation here. And we've already done an example of the quadratic equation, so if you want to take the quadratic equation and plug it in and solve it out, please do that. Take a little extra time and do that. If you have any questions on how to do that or you get stuck doing that, let me know. I'm going to go straight to the calculator and solve it through and leave it up to you to try the quadratic equation at least one time on your own. So let's go over to TI, take this equation I just circled in blue, and figure out what the year is. Okay, so let's do that. Alright, so what I did was took that equation I had circled in blue and I put it in for y1. So go ahead and do that if you haven't. And I'll show you a secondary method of doing this as well, if you'd like a secondary method after we do this primary method. So I've already put this in here. Okay, so once I've done that, I can go to zoom standard. I can already tell you it's probably not going to show up. I can do zoom fit, and what I'm getting looking kind of like this. Okay, so I'm going to zoom out a little bit and see if I can get a better picture, because I want to know when it crosses the x-axis. That's what I'm really curious about. Okay, and I'm really curious about where it crosses the x-axis on the positive side. So I'm kind of seeing it. I'm missing it up here a little bit. I'd like to see where it actually crosses the axis, and there it is. So it crosses in two places, obviously, but if you're thinking about the logic of the problem, it says years since 1970. So 1970 is year 0. Okay, it's not worried about previous years, so we don't need to go negative. We don't need to go before 1970. We need to go after 1970. So the point we're interested in is going to be right here where my cursor is at. So it's going to be right here. So let's find that where it crosses the x-axis. We'll go second calc 0, and we'll go left of it. So we're still left of it here. I'll hit enter. We'll go right of it. I'll hit enter. And then we will actually kind of guess about where it's at. Say right there, hit enter. And what we see is that x equals approximately 54, y equals 0. So our answer here is going to be x equals 54. Okay, so keep that in your mind. If you get something, I mean, this is 53.9999667. It's approximately 54. Okay, so keep 54 in the back of your mind, and I'm going to show you the second method you could have also used if you went straight to the calculator. Now, if you went straight to the calculator and didn't want to do any of the initial solving that we did, what you could do is you could start with that very initial equation. So it looked like this 2.29 whatever, and then we had a 353.3, I believe. Yeah, I believe that's it. And then we wanted to know that 5,227. Okay. So what you could do is you could let your y1 be your original equation. Oops, and I need to add. Looks like I forgot to add the positive in here. So second insert positive. Okay. So this is our original equation up top. This is when we wanted to know when it would reach 5,227. If I hit graph, okay, it doesn't do a very good job of showing it. So let's do zoom, I don't know, zoom fit again, see if it helps. And what we see is it crosses and intersects each other. Okay, so once again, what I'm interested in here is actually the intersection of these two lines. But I'm interested in it on this right hand side. So my first curve's here, my second curve's there. I'm not interested in where they do it before 1970, which would be on this side. I'm interested in where they do it after 1970, which is on this side. Hit enter, and what you find is you get the same thing. X equals approximately 54. Okay, so there's your two methods that you could use on the calculator to do it. Now let's go back to the paper. You can also solve it quadratically by hand, which is something you need to do on your own, and then let me know if you have questions for. Let's go back to the paper and get the answer down. Alright, so what we found here was that our answer here was x equals 54, or approximately 54. Now that's not our final answer. It says find the year after 1970. So what we're really looking for is 1970 plus that 54, which should give you 2024. 2024 is the answer that they would be looking for. Easy enough. Okay, the discriminant. So we can determine the types of solutions of a quadratic equation has by looking at b squared minus 4ac, which is called the discriminant. If b squared minus 4ac is greater than 0, we have two different real solutions. If b squared minus 4ac equals 0, there's one real solution. And if b squared minus 4ac is less than 0, there's no real solution. Now the reason this is if you look at your quadratic equation, negative b plus or minus the square root of b squared minus 4ac all over 2a. If you're looking at this, the discriminant is the piece that's under the square root. So if I have a positive number under my square root, then I'm going to wind up with two real solutions because it's going to be a b plus or minus two different numbers. Okay. If it's 0, I'm only going to have one real solution because the plus or minus goes away because this times a 0. And I get my real solution is going to be negative b over 2a. Okay. If I have a negative under the square root, so my discriminant's a negative, I can't take the square root of a negative and wind up with a real solution. I wind up with an imaginary one. So that's kind of how the discriminant plays out and works. So essentially what we're going to do with these examples here is we're not going to solve them out. We're just going to say how many solutions they have and if they're real or not. So if I look at this, my b here is 4. So I wind up with a 4 squared minus 4 times a, which is a 3, and then c here, which is a 2. Now, 4 squared is 16, okay, minus 4 times 3 is 12, times 2 is 24. So what I wind up with here is a negative number. I actually wind up with looks like what, a negative 8, is that right? So I have no real solutions. Okay. Now, here, number 2, let's do it. So my b here is a 4, so I get 4 squared minus 4. My a here is a 1, and my c is a 2. So that what I get is 16 minus 8, which is a positive 8. I've got a positive 8, which means I have two different real solutions. Okay. Now let's look at this one. So b squared, negative 6, you got to square that negative part too, minus 4 times a, which is 1, and c, which is 9. So that what I get is negative 6 squared is 36, minus 4 times 1, which is 4, times 9, which is 36, which is 0. So I have one real solution. And you could go on and solve all of these with the quadratic equation and come up with solutions, obviously, except for the first one, where you could actually come up with a solution, but it would be an imaginary solution. On to page 4. So if we look at it, speaking of the imaginary, if we look at equations with complex solutions, if x squared equals negative a, where a is greater than 0, then x equals plus or minus the square root of negative a, which equals plus or minus the square root of negative 1 times the square root of negative a, which is equal to plus or minus the square root, and this is incorrect here. So let's rewrite this, see if you're paying attention. Plus or minus the square root of, it'll actually be I square root a. Somehow the I got left off there when I was typing up the notes. It happens. Okay, so that this I is essentially equal to negative 1. So if you've never heard of that, I equals negative 1, or square root of negative 1, okay, because I squared equals negative 1, okay. So if we're going to solve this, so what we have here, we've got x squared equals negative 9, so that means that x equals plus or minus the square root of negative 9, okay, which means that that is also equal to plus or minus I square root 9. And we know what the square root of 9 is. Square root of 9 is just 3. So what we get is plus or minus 3i. And it's that simple. So if we do this one, solve it for x, 3x squared equals negative 24. Okay? Because all I did was move this 24 to the right hand side. Now if you divide by 3, you get x squared equals negative 24 divided by 3 should give you negative 8, right? Okay. Now that means that x equals plus or minus the square root of negative 8, which means that x equals plus or minus I square root 8. And we can split that 8 up if we want to into a 4 times 2, and we know the square root of 4 is 2, so that what we get is x equals plus or minus 2I square root 2, and that will be the final answer we're looking for here. Okay, and last but not least, we have two complex solutions of quadratic equations. So what we're going to do here is we're going to use a quadratic equation. Okay, negative b plus or minus the square root of b squared minus 4, a here is your 1, c all over 2a. So your a here is 1. Okay, if we simplify this, what we get is a positive 3 plus or minus the square root. We've got a 9 here minus 20 over 2. And if you need to take a few more steps to figure that out or pause it to catch up, I know I'm getting to go faster and faster, but as we progress in this class, you should be getting a better and better hang of things and be able to move through this a lot quicker. But if you need to take a little extra time, take a little extra time, pause, figure out what I'm doing here. All I did here was negative 4 times 5 times 1 is negative 20. Okay, simplify it out a little bit more, we get 3 plus or minus the square root of negative 11 over 2. Okay, so that we actually have two solutions here, and you can't really simplify this. So one of our solutions is 3 plus the square root of negative 11 over 2, and the other is 3 minus the square root of negative 11 over 2. But what you're going to want to write here, you're going to want to get rid of that negative in the square root, so that what it looks like is 3 plus or minus I square root 11 over 2. Okay, so that your one solution is 3 plus I square root 11 over 2. The other solution is 3 minus I square root 11 over 2. Okay. Now, let's look at the last one on the page. And now we'll change colors for it. We'll just go plain Jane black here. Okay, so we've got 3x squared plus 4x equals negative 3. Now, if we're going to use the quadratic equation here, let's put it all on one side. So let's add this 3 over and get it on the same side. Okay, now we're looking at negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is 3. Okay, so if we come over here and simplify, we get negative 4 plus or minus, now 4 squared is 16, 4 times negative 4 times 3 is negative 12, negative 12 times 3 is negative 36, all over 2 times 3 is 6. Okay, so that if we simplify a little bit further, we get negative 4 plus or minus, now 16 minus negative 36 is negative 20 all over 6. Okay, now we got to simplify that square root. We get negative 4 plus or minus. Now I know I can go ahead and pull out an I, but I can also break that 20 up into a 4 times 5 because I know what the square root of 4 is. Okay, and that's still all over 6. So that if I do that, I get negative 4 plus or minus I times square root of 4 is 2. So you can write I2 or 2I. I always prefer to write 2I, so let's write it that way. I like to write my numbers in front of my eyes. That's just me. So let's get back to where we're at here. So 2I square root 5 all over 6. Now they're going to want you to take this and simplify it just one more time at least. And what they're going to want you to do is essentially they're going to want you to see that you could pull out a 2 here or cancel out a 2. So I can cancel a 2 out of this 6, I can cancel a 2 out of this 4, and I can cancel a 2 out of this 2I square root 5. So that what it simplifies to here is negative 2 plus or minus I square root 5 all over 3. Okay, and those would be your two final answers. So one of them would be -2 plus I square root 5 over 3. The other would be -2 minus I square root 5 over 3. And that completes chapter 3.2. Let me know if you have any questions. Send me an email, let me know. Other than that, make sure you're staying on top of your homework. And if I see any questions, always feel free to reach out to me and let me know.